So we have a 65 kilogram football player running to the west at 2.5 meters per second. This football player tackles a 70 kilogram football player running to the north at 3 meters per second. What is their velocity immediately after the tackle? And we're going to assume that the first football player is able to tackle and hold on. So he's held on as they move together for an instant before they fall over. So this guy's running to the west. As this guy's running to the north. Those are their velocities the instant before they collide. What direction do you expect their velocity to be in?
Southwest and northwest. Mixed.
Some combination of north and west. Okay. Now momentum. Momentum's a vector, just like force was a vector, velocity is a vector, position is a vector. Just like we have with all of our other vectors, when we add vectors together, we can still only add x components together to get resultant x components. We can only add y components to get resultant y components. So when we say that the initial momentum of the system is equal to the final momentum of the system, that's totally, vectorially. The total momentum vector initially has to equal the total momentum vector finally. But since we can only add x components together to get x components, we can also say that the initial momentum in the x direction for the system has to equal the final momentum in the x direction for the system. And likewise for the y direction. We did this with forces. We added up forces in just the x direction. And that gave us a resultant acceleration in the x direction. Same reason. In terms of momentum, the x components added together initially will determine the x components finally, and vice versa for the y. So for our system, let's look at the x components first. This guy has momentum in the x direction initially. It's headed towards the left, so we can say negative. His mass is 65 kilograms. His speed is 2.5 meters per second. Negative because he's headed to the left. What about the 70 kilogram football player? It's only in the y direction, exactly right. So he will have no momentum in the x direction. You can put a +0 for him. Or you can just not do anything for him. Either way. So the total momentum in the x direction is completely determined by our 65 kilogram rudder. Finally, well, if the first football player is able to hold on to the second one, they'll be moving together right after the tackle. And so we'll have a total mass of 65 kilograms plus 70 kilograms. So the final momentum is the total mass times the final velocity, but just the x component. The momentum in the x direction initially will only give us the x component of the velocity finally. That's fine. That's one piece of information at least. I get negative 1.2 meters per second. What that is this component. That's just the x component. It's to the left, and it has a value of 1.2 meters per second. We're not done though. The velocity has x and y components. So we need the y component as well, which we'll get looking for momentum in the y direction. In the y direction, the 65 kilogram player has no momentum. So his momentum is 0 initially. The 70 kilogram football player has momentum. His mass is 70, his speed is 3 meters per second. He's headed in the positive y direction, so that is his momentum initially. That is the total momentum of the system in the y direction initially. The momentum is determined solely by the 70 kilogram player in the y direction initially. Again, that has to equal the total mass times the y component of the velocity finally. Okay? Whatever momentum you have initially in the y direction, you have to have finally in the y direction, which will allow you to solve for the velocity in the y direction only. So 1.6 meters per second. So if we have our components, you know those meet at a right angle, we can easily get the magnitude. Using the Pythagorean theorem. Well, that's convenient. 2. But we're not done. Velocity, remember, is a vector. Magnitude is not enough to designate it. So 2 meters per second. Let's see, how do I do it? There we go. This angle is 53 degrees. North of west or west of north?
West of north.
To get up to 53, we need to start at west and go north. So it's north of west. Yes?
So you had components of velocity.
Uh-huh.
Could you solve that?
You could find the components of the momentum and find the total momentum overall and divide by total mass, and that would give you the total speed. Yeah. That would work just fine.
And then that works.
It would have given you the correct angle too. Yes.
Couldn't we also treat those two as vectors, you know, in the I hat and J hat?
We basically did. We
Yeah,
just separated it up and looked at i's.
Before you put it together.
Certainly. You could certainly write them in terms of I hat and J hat and work your way through just adding I hats and setting them equal to the I hat components, yes.
Could we write the angle as 127?
Sure.
That's fine.
That would be fine as well. By the way, not all collisions result in objects sticking together. The examples we've done, they've stuck together. And that's primarily because we need to know a final velocity of one of them in order to find it for the other one. And rather than make up a final velocity, because that can throw things totally out of whack, I decided to make them stick together, and we didn't need to know. But the process would still be the same. What would be different if these guys, so the football player was able to knock the other guy over but not hold on? How would that change the problem? We can't add their masses because they wouldn't be moving at the same speed. So we would have to keep them separated. Football player 1's momentum plus football player 2's momentum. We would need to know the velocity of one of them after, so that we could know the final momentum of one of them, so that we didn't have too many unknowns. But the only difference, if they do not stick together, then you keep them separate. 65 kilograms times V1 X final plus 70 kilograms V2 X final. You would keep them separated out as individual elements. It's the only difference. Questions?